Assalamualaikum warahmatullahi wabarakatuh. Today we will continue our lab session, which is this is our last lab. So the lab session for today is actually the counter circuit. Okay, I will show you how we can draw the counter circuit. Right. So as you can see in this word, yeah, this is actually the JK expressions. So I will draw the counter circuit based on these expressions. Right. So open your counter circuit, your circuit breaker. So this is your circuit breaker. So I will draw these expressions, right? Okay, so first thing we need to add the flip-flop. Okay, so based on this is equation, you need to have three flip-flop. Okay, each for each variable. Okay, so one for each variable. So you have three variable A, B, and C. So the flip-flop. So you click device and then you click browse, okay, to search or to find the flip-flop. Okay, so browse. Okay, and then for the major device class, you click digital basic. Okay, major device class, digital basic. And for minor device class, you choose flip-flops. And then device symbol. Okay, so you have several symbols here. So you choose JKSR. Okay, so JKSR. So this is a symbol for flip-flop. Okay, the JK flip-flop. Okay, and then you click place. Okay, so you put here. Right, so as usual, you can disable the designation here. Okay, you want A, so I want you to disable the designation. So just remember how you can disable the designation or the name of the device or the label. Sorry, the label of the device is you just right click on the device and then you click edit device data. Okay, so this is the designation. So you click on the visible menu. Okay, so and then you click OK. So the designation will be disappeared. Okay, so because you have three variable, meaning that you need to add another two flip-flop. Okay, you just can copy and paste, or you just can right click and then duplicate. Okay, so you also can use this menu. Okay, and then you put somewhere right here. Okay, just put a bit space, okay, between the first flip-flop and the second flip-flop, because maybe we need to add some gates. Okay. And then copy and paste another type, another flip-flop here. Okay, so now you have three flip-flops. So I will show you the basic diagram of the counter circuit. So the basic diagram, you must have the flip-flops, you must have the clock, and you must have the label of your flip-flop, which means you need to label your flip-flop as A, B, and C. Okay. Right, so next is the clock. So you click devices. Okay, and then click browse. Okay, now you choose digital. Okay, major device class is digital. Okay, and then minor device class is instrument. Okay, and then device symbol is pulse. Okay, pulse. So pulse is actually referring to the clock. Okay, and then you click place. Okay, click place and then put somewhere right here. Okay, so again for this clock, I want you to rename as a clock, not V1. Okay, so how to rename is really the same way how you can remove the designation previously for the flip-flop. Okay, so you just right click on the clock and then edit device data. Okay, designation instead of V1, you rename as clock. Okay, and then click OK. Alright, so now the next device is the display, logic display, which is we want to connect it to the each flip-flop for labeling. Okay, for the labeling of the flip-flop, so we will use the logic display, which is the LED. Okay, so the LED is under hotkeys 1. Okay, hotkeys 1. Okay, and then choose logic display. Okay, and then you put somewhere right here. Okay, and then rename as variable. Okay, for the first flip-flop, this belong to A, so instead of L1, so you rename as A. Okay, and then you can copy and then paste to another flip-flop and then rename as the variable. For the second one is B, and then for the last flip-flop is for C. Okay, this is for C. Okay, right, and other than this logic display, I also want to include another type of display, okay, which is the hex display. If you can remember in chapter 5, you have learned the device. Okay, the hex display we used to display the number, the decimal number, because this is a counter circuit. So when we have the hex display, it is easier. We can see the value or the number that can display based on the counting sequence. Okay, if you don't want to put the logic display, it's okay, but you also can see based on the switch or the LED. Okay, so when the LED is switched on, it's referring to the value 1, okay? But it's quite hard if you want to read based on the LED. Okay, the switch on based on the LED, right? So we need something or device that can be read much easily, okay, the value or the decimal number. Yeah, so we will add another type of device, which is hex display. So hex display is under hotkeys 1. Okay, so here hex display, so you can put around here. So I think I need to, okay. So this display will display the value. Okay, so I will show you until the last result. Okay, alright, so done with the basic device that we need for the basic diagram of the counter circuit. So next, we connect, okay, the devices. Okay, by using this menu, which is the wire tools. Okay, so you click on wire tool menu, and then you will connect all the devices. Okay. So first, I will connect the queue, okay, for each flip flop to the each logic display. Okay, we start with the A. Okay, so you connect the first queue to A. Okay, and then second queue to B. Okay, and then our last queue okay, connected to C. Okay, and then next we will connect each line, okay, to the hex display, okay, on top. So based on the hex display, if you can see, we have 4 pins, right? Pin number 1, number 2, number 3, and number 4. But our variable, we only have 3 variables. Okay? So you must remember how you can connect each pin to each variable. So the last variable must be connected to the pin number 1. Okay, for example, for this counter circuit, the last variable we have is actually C. So line C must be connected to pin number 1. If you have D, okay, flip-flop D, so line D must be connected to pin number 1, and then the next variable, okay, connected to pin number 2, and next is pin number 3, and so on. Okay, So first we connect line C, okay, with pin number 1. Okay, and then pin number 2, okay, must be connected to line B. So actually this method is actually the same method as you have learned in lab chapter 5, okay, which is arithmetic circuit. Okay, if you can remember, okay, the parallel adder circuit. Okay, so I have taught you how to draw that circuit, right? So this is actually the same way, okay, how we can connect the display. Okay, so and then last pin is pin number 3, so connected with line A. Okay, so next we will connect the CP, which is the clock, okay, on each flip-flop. Okay, so the first CP here. Okay, so connected with your clock. So your clock, you have two Q, right? Q1 and Q2. So you must connect to the Q1. Okay, Q1, right? So same goes with the CP for B. Okay, also connect with the same line. Okay. And the last CP for A also must be connected to the same line. So we done with the connection between all devices, which is the basic devices for the basic counter circuit. Okay. So we will proceed drawing our counter circuit, okay, based on these equations. Okay, so based on this equation, which is JA equal to 1, KA equals to B exclusive C, and so on, right? So we put here. Okay. So as you can see, based on these equations, so we did several devices. As example, for JA is equal to 1. So you need to insert the device that representing 1, okay, in your counter, in your circuit maker. So the device that representing 1, you can find, or you can search based on the menu devices. Okay, hotkeys 1. Okay, the second menu, okay, which is positive V 5 volts. So positive V 5 volts is actually one device that used to represent value 1. Okay, and then ground, on top is ground. So ground is actually a device that can represent value 0. So if your equations, okay, have the expression that equal to 0, okay, for example, KB equal to 0, right? So 0, you can use this device, which is ground. Okay, and then positive V5 volt is actually representing 1. So you choose this device, and then you put somewhere right here. Okay, so this device also, I want you to disable the designation, which is the V1. V1 is actually the designation or the label, so I want you to disable. So how to disable? Okay, you just double click. Okay, and then you click visible. Okay, so no V1 here. Right, so next device for KA. So KA is B exclusive C. So meaning that you need to add exclusive OR circuit. Sorry, exclusive OR gates. Okay, so devices, hotkeys 1, okay, exclusive OR. Okay, two input. Two input exclusive OR. So you put here. Okay, and then disable the designation. Okay, so for JB we need OR, okay, A bar plus C bar, okay, which is OR. For A bar and C bar, you don't need to insert the NOT gate. Okay, if you can remember, a NOT gate is actually already have in your flip-flop, which is you have Q bar, right? Okay, so Q bar will representing NOT for the variable. Q is non-complement for the variable. So for example, for A, so Q, this line Q is actually representing A. So Q bar here is actually representing A bar. So same goes with the B flip-flop. So Q bar for B flip-flop representing B bar. And then the last C flip-flop, so Q bar for C flip-flop will representing C bar. So the That's why if your equation have complement, which is A bar, B bar, C bar, so you don't need to use NOT gate. Please don't use NOT gate. Okay, so if you use NOT gate, it's actually totally wrong. Okay, because you already have the value that representing the complement value. Okay, so that's why for JB you only need OR gate. Okay, so to input OR, yeah, so you can insert here. Okay, and then disable the designation. Okay, KB is C, so you don't need any gate. Okay, JC is A bar and B, N, so you need AND gate. Okay, AND gate, so you can put here gate. Okay, disable the designation. KC A bar, so this one also you don't have to use any gate. Okay, because you already have A bar. Okay, so I think we already insert all the devices that we need. So for our last step, we connect all the devices, okay, to the output, which is JA, KM, so on, right? So again, we use wire 2. Okay, first JA. So this is your JA. So your JA must be connected to 1, which is 5 volts. Okay, and then your KA. So KA, okay, connected to XOR. Okay, and then for your XOR, you have 2 input, right? So first input, okay, so here, okay, you connect with B. Okay, this line B. And the second input is C. Okay, so the second input, okay, you connect with the line C. So this is your line C. So done with your A. Okay, so we move to JB. So JB, A bar plus C. So first you connect the JB to the OR gate. And then first input is A bar. So here is your A bar, which is Q bar for flip-flop A, right? Okay, so you connect with the Q bar for flip-flop A, representing the A bar. And the second input for OR is C bar. Okay, so C bar. So this is your C bar on the flip-flop C. Okay, Q bar on your flip-flop C is C bar. KB is equal to C. So you already have C line on top of the circuit. So you just connect, okay, your KB to C line. Okay, so this is your C, right? Okay, so KB is equal to C. So or any other parts on the C line. Okay. And last for C, okay, JC. So JC, first you connect your JC with the AND gate. And the first input is A bar. Okay, so A bar. Okay, so you find the line A bar. So this is your A bar, right? Okay, so this is your A bar. So you just connect with the line A bar. And then the second input is B. So this is your B. So this line representing B, right? So you just click, okay, and then connect with your B. And then lastly, KC is A bar. So we already have the A bar line here. Okay, you just draw this line. Your KC must be connected to this one. Okay. So done with the connection. Okay, the connection between all the equation. Okay, for your JA, KA, JB, KB, JC, and KC. Okay, so now we will test the counter circuit. Okay, but before you test the counter circuit, okay, you have to make sure that your simulation speed is suitable with the speed that you need. Okay, because by default the simulation speed set as 30. So 30 is the fastest speed. Okay, so how you can change the simulation speed, okay, you go to simulation menu, okay, and then choose digital option. So you can see as simulation speed here by default is 30, right? So 30 is actually the fastest. Okay, so I will show you what happen if you don't change the speed. Okay, so click cancel. Okay, so I just run, okay, this counter circuit. Okay, before you run, you have to make sure that this mode, okay, must be changed to N mode. Okay, by default your mode is actually uh, analog, okay, because the symbol is transistor. Okay, here, so you just click on the transistor mode to change to AND gate, okay, meaning that the simulation now will change to digital. Okay, so you can see on uh, the label top, okay. And then after you change the mode to AND gate, okay, you can click this icon, okay, used to run or stop the simulations. Okay, so I click here. So as you can see, the display, okay, so you can see the number is actually changing, but you cannot read the number because the speed is uh, use the faster speed, right? Because we use the 30, okay, the value is 30, right? So you need to change the simulation speed. So that's why before you run the counter circuit, you go to the simulation and then you choose the digital option. And then for the simulation speed, you can choose any value as long as when you run the counter circuit, you can read the value. Okay, for example, I choose 3. Okay, I choose 3. Okay, I change to 3 and then I click OK. Sorry. Okay. Okay, so now we test again. Okay, we run again. What happened to the counter? Okay, so you see the display. So now you can read. Okay, you can read the value. Okay, 5, 1, 6, 2, 7, 5. 1, 6, 2, 7, 5. So meaning that this counter circuit, the counting sequence is again 1, 6, 2, 7, 5. And I repeat again 1, 6, 2, 7, 5. Right. So that's why we need to use this hex display to make sure that uh, we can read easily what is the value, yeah, the counting sequence. If you don't put the hex display, you also can interpret the value based on this LED, okay, the light, okay, on the LED, so you can read, okay. Right, so this is how we draw the counter circuit. Okay, so I hope you can follow my instructions. Okay, for the last lab session, okay, which is the counter circuit.